Welcome back to a new video. Today's video we are going to learn about object expression, object declaration, and anonymous classes. We have seen in previous videos how we could create an anonymous function just like the one we see here. It's just a function without a name that acts as a normal function and we could save it in a variable. And our variable is going to be of the type of a functional type like we see here. And whenever we're going to use it, we are just going to pass what it takes within its arguments, and it's going to act as if it was a normal function. And today we are going to learn how to make something similar but for classes. So we see here we have an interface can do a job which has only one function, and we have an abstract class person which has these three properties in its constructor and two more properties within its body, just this one, the adult, and the member function print info. Great, so whenever we want to create an instance of these two abstractions here, we cannot because they are abstract, obviously. So we could create a class that extends or inherits from the abstract class, and we pass our values. Then we implement the methods, and finally we also implement or inherit from the interface, and we implement the interface function. That's cool. But as you can see here in our class only is considered to be of one-time use only. So we only passes the my key name and cooking and 18. So these are static values. So if we wanted to make this class more flexible, we could pass these values here when we create our constructor. So for every instance of adult that you make, you could pass the values here, and you could make more than one instance that have different values for these properties here. But as I said, I have designed this class to be for one-time use only. So whenever you have this use case, you would use something called anonymous class, and instead of creating a whole class to do this for you. So now let's learn the syntax of creating an anonymous class. And here I'm going to make val adult, and my adult is going to be of type person, so the class that I want to inherit from. And then I'm going to assign the adult to something called object or object keyword. So object keyword here allows you to create an anonymous class, and it acts as if it was a class that extends from or inherits from another classes. So the syntax is similar. You just add the colon to give the lists or the classes that you wish to inherit from, like the person. And here I'm going to pass the name of the guy, which is Mikey, and then the age, for example, 18, and finally the job. So cooking is the job. That's cool. Now to add the interface, it's just similar, the same syntax, add the comma, and can do job. And whenever you're done adding your parents or super types lists, you add the body of this object here. And now the object is going to give you an error because you have to implement the members of person and cooking that you extended from your object here. So just very similar as if as you were just making a class that inherits both of these abstractions here. What you're going to do is just going to press Ctrl I, and you're going to implement all of them. So as you can see, members from the person class and one member of can do a job. So I'm going to select all of them and press enter. That's cool. So now we are having the same, pretty much the same syntax. So val of ride for the is adult, same here. Print info and can do job is also here. So what we're going to do is just add the same functionality that we have, or the same implementation for both of these functions. And now we could get rid of our adult class here as it's not useful anymore. Now let's just discuss the syntax of anonymous classes. So you make a variable just like you would normally do. You assign it to a value. So our value here is going to be the object keyword. So the object keyword, whenever you assign it to a value, you are saying that you are about to create an anonymous class or object expression. So this is called object expression. So our object or our anonymous class inherits from person, the abstract class, and the can do a job, which is an interface here. Great. Finally, you open the body and the IDE will ask you to override the abstract members of these two classes here. Then you're going to override them and you add your own implementation just like you would normally do with a regular class. That's cool. Now let's just try to access these functions here from our adult. And if you check the adult type, it's of type person as we have specified the type explicitly here. Now let's just uh, see if this person is an adult or not. So I'm going to print ln is adult, is it adult dot is adult, and then I'm going to print the info. So I'm going to call the print the info method or function print info, and finally I wish to call do job. And as you see here, we cannot call do a job as it is a function from the interface. If you check function with an interface called fun do a job. But what's the solution here? Well, the solution is that we have explicitly set the type of this variable to be of type person. So we cannot call any functions within any type or within any class rather than person class. And person class does not have the do a job function. So for that, we are going to let the IDE infer the type for us. So we're going to delete the type here. And as you can see here, we can call do a job, as this adult now is considered to be an object or an anonymous object that extends or inherits from person and can do a job. So it's like having multiple types at the same time. So I would always encourage you not to specify the type of your variable that has been assigned to your anonymous class and leave the type inference for your constructor. Great. So now let's just run the program and verify our output here. So I'm going to click run. And here comes the result. So is adult true? Yes, it is, because the age that we passed to the person's constructor is greater than or equal to 18. Then my name is Mikey and my age is 18. This is just a result of calling the print info function. And lastly, we have cooking, which is the result of calling the do job function, which comes from the can do a job interface, as we have implemented this interface. So we were required to implement this function as well. What we have seen so far was called object expression, as we use the object keyword and we assign the calculations or the operations where we did all this inheritance stuff to some kind of a variable. Now it's time to talk about object declaration. But before that, I'm going to have an example. Why do we need object declaration? So here I have a class called counter, which has one property only and called current counter, and its initial value is equal to 0. And whenever we call this current counter, whenever we're going to print it, we're going to have the previous value, then we're going to increment it by 1, and the second time we're going to have the previous value, then again increment it by 1, so on and so forth. And here we have another initializer, which is the set. We set it to a private initializer because we don't want anyone outside of this class to modify our current count. Cool. Now I'm just gonna make an instance of this counter class to see how it works. So val c is equal to c1 is equal to counter, and here it doesn't have any arguments, so empty constructor. And now I'm gonna print c1 dot current count. So at the beginning we expect to get 0. Then whenever we call it again, we expect to get 1 because we incremented the last time we call it, and here 2, 3, and so on. So 0, 1, 2, 3. Now let's run the program to just verify our output before we get into another topic. So 0, 1, 2, and 3, because every time we call it from the get initializer, we increment it by 1. That's cool. Now, whenever we call C again or whatever, we are expecting or we expect to get the value incremented. and say for instance I'm going to make a new instance of my counter class called counter2, and then I'm going to print the same for our counter2 here. Just make sure to make it c2 because to refer to this instance. And whenever we run, I'm just going to have a little separator here, println running c1. Let's copy this, put it here, running c2. So now we expect to have 0, 1, 2, 3, 4, 5, 6, 7 as both refers or points to the same class. Well, maybe let's just run and see the result. Here we got 0, 1, 2, 3, and when we create a new instance and we called the current counter again, we got 0, 1, 2, and 3. Okay, why is that? Well, whenever you create a new instance of a class, it acts as brand new instance that doesn't have any relationship with any previous created instances. So both of C1 and C2 here act as different or separated entities. So whenever we did this, the counter was at 0, and whenever we did this here, counter was at 0, and say for example I'm going to make a new instance called C3, the counter also will start at 0. And whenever we call it in the C2, we're going to start 0, 1, 2, and 3. Similarly for C1, 0, 1, 2, and 3. And just to verify what I'm saying here, I'm going to print the string representation of these two. So we have any class in Kotlin or in Java have a toString method, which just prints a string that represent these objects. So I'm just going to print ln C1. You don't have to worry about what I'm saying here. I'm just going to want to prove that both of these instances are different. So as you can see, C1 prints 34CE48 and C2 print B684. So both are different. Both have different string that represents both of these. Now, what if we want to have the same instance? What if we want, whenever we create a new instance of the class, we want it to point to the same instance? So this is called singleton pattern, and it's a very popular pattern. You could find it in any programming language. And in Kotlin, it really helps you and simplifies creating this singleton pattern. So whenever you want that singleton pattern, you only have to change the class keyword to an object keyword here. And here comes the difference between a class and object. So an object cannot have a constructor, and so you can just delete it here. And whenever you try to add the constructor, so example val x of type string, you're gonna have a syntax error. Now, whenever you create a new instance of an object, it will point to the same instance. So C1 is the same as C2. Now, let's just print their string representation text to verify the output. And here we have 34CE8AF7 for both of these. Though they are different variables, but they point to the same instance or to the same reference. Now, let's try our last example or the previous example. So running C1, and here I'm going to have println C1 dot print count 4 times, then running C2. I'm just going to have this here, running C2, both of these to 2, and we are going to run a program. And here we have the output. So whenever we increment from C1, 0, 1, 2, and 3, we create a new instance of C of the counter class called C2, though it points to the same or the previously created instance. So whenever we call current count again, we get 4, 5, 6, and 7. So both are the same. All you need to know about object classes that they are a class in the end, but they are only declared with an object. And whenever you create a new instance of this class, it's going to point to the same previously created instance or reference. That's cool. So, for example, whenever you had to access some properties or some members of any class, you had to create a new instance first. So for instance, I'm gonna have a class called person, and this person gonna have val name of type string equal to something. And whenever I want to act or I want to Whenever I want to access this person name, I have to create an instance p equal to person, and then I'm just gonna print, or we're gonna access person p dot name. That's cool, that's right. But can we access this with the class name, for instance? Let's try this. P dot or person dot name. See, you cannot, because this variable here or this member here is a member of this class, and to access it you need to create an instance. On the other hand, object, you don't have to create an instance in order to access its public members, or its public members, yes. So for that, I'm not gonna create an instance of our public counter. What I want to do is just call the member with the class name. So it's gonna be public to be called from the outside. And now I'm just gonna call it multiple times and run the program just to verify our output. Here we got 0 to 8. That's also another difference between object and regular classes. We know that you cannot add a constructor to your object class. So what if you want to add a constructor to your object class and in the same time you want to keep the capabilities that the object class gives you? Well, to do that, all you gotta do is just to convert your counter class or the object class to a normal class. And now you can add the constructor. And within the class body, you add the object as a member to this class. So here you type companion object and you open the body of the object. So this now tells the compiler that this object here is companion to our normal class right here. And whatever you want to call with the class name only, like counter dot something, you add it within the object body like so. So now we could call the current count without creating an instance of our counter class. And for many instances that you make for our counter class here, the current count will be the same. So let's try this. So here I'm just going to have a name. So val, for example, c1 is equal to counter, and I'm going to pass Mikey as the name. Another one, I'm going to name it c2. I'm going to pass John as the name. So now let's just verify that both are different instances, c1 and c2. Let's run the program. And here they are different. So 5.7 and for the John 1.9. So they are different instances because they are declared with the class keyword. And now if we try to access the current count with our created instances, we will not be able to. We only have access to the name as the name is a member of our counter. And if you wanted to access the current count, we have to create, or we have to call the class, then the current count. But this is not what we want to achieve. We want to make this class have the same abilities of the object class like before. For that, I'm just going to make a new member here. And that member is going to be called, for example, counts. And our counts is going to be of type string. And I'm going to make our counts here equal to our current count. So here, I'm just for the get initializer, I'm going to pass current count. So we're able to access it within the class itself. Now, say for instance, C1 is going to call the count, and C2 is also going to call the count. So we expect to get 0, 0 if it was a normal class without a companion object. But it has a companion object, and we have a member that has a reference to the values within the companion object. So we now expect that this class acts as an object, and we get 0 and 1, because every time we call it, as we have said before, we increment it by 1. Last thing to add about object declaration or object classes that you can also implement or inherit from other classes. So for instance, I'm going to have my object here that implement or inherit from my interface here. As you can see, we could implement our function, which is the testing function, and whenever we want to call it, we don't have to make an instance c equal to my object. It's fine if you wanted to, my object, and we could call c.testing, or we could directly call my object.testing. So that was it for today's video. We learned about object declaration, expression, companion objects, and anonymous classes. I hope you enjoyed or at least learned something. So have a nice day and see you in the next video.